everyone. It's good to see you all. Looks like we have about 32 people here. I think we can go ahead and get started. So thank you everybody for being here. For anyone who has been with us for a while, you're probably used to Paul, but today you have me. Hopefully I can do this justice. So today we're going to be talking about exercise and the research around the use of molecular hydrogen in exercise science. I do always want to point out that none of these claims are evaluated by the FDA. If you have questions about how to use molecular hydrogen in your medical routine, you really need to take that up with your medical team. And I will point out that all of the studies that we're talking about today have links on the bottom, and you can look up any of these and bring them to your medical professionals. But I'm not here to bring you medical advice. I'm here to talk about the science. A little bit about me. So I'm actually the lead scientist here at ECHO. I have been with this team about 5 years, and I just want to tell a little bit of a story. So the founder of this company about 5 or 6 years ago wanted to really understand the research space. He really wanted to understand what research had been done, what questions had been answered, what questions are outstanding, and that's why I was brought in. And I will say I was completely naive. I had never heard of molecular hydrogen other than, in terms of chemistry. And I'm a pretty skeptical person. And I thought, okay, well, I will take a critical eye to it and we'll really, we'll assess the research and see what we've got here, right? Do we really have something, or is it all malarkey? And sure enough, I was actually pretty impressed with the research. I was impressed with the findings. And as you can see, I am still here working on molecular hydrogen research. So I guess the science made me a believer, and I hope I can make you a believer too. Before we get into exercise, I do want to point out something that's really important, right? That hydration is really the foundation of health. Our bodies are about 70% water. Our blood is, 90+% water. And if you are poorly hydrated, particularly chronically, you are going to have problems. Your circulatory system won't do very well. Your lymphatic system won't be doing what it's supposed to be doing. Even your cells, begin to become dehydrated and they stop functioning properly. So hydration is really one of the key elements of health, along with nutrition, exercise, lifestyle factors, good sleep, and of course, vitamins and minerals and a good diet. So I do want to just point that out. But let's get into the topic that we're here for, right? Which is exercise. So I should hope that many of you will probably know physical activity is a good thing. There is a pile of research showing all of the benefits of regular physical activity, including adding years to your life, right? Improving your sleep quality, improving your mental health, lowering your all-cause mortality risk. So that means anything that you can die from is considered all-cause mortality. And research shows an 11 to 40% reduction in dying from literally anything if you get regular exercise. Also, lower risk of type 2 diabetes, dementia. And this is really just the tip of the iceberg in terms of the benefits of regular physical activity. But exercise does trigger a transient pro-inflammatory response. And in biology, we call this process hormesis. So hormesis, or hormetic stress, is anything that causes a transient inflammatory response that actually makes you stronger later, right? So it kind of invokes the saying, anything that doesn't kill you makes you stronger. exercise is definitely in that bucket. So exercise is associated with huge increase, acute increase in inflammatory markers and immune activation. And these things are actually integral to the benefits of exercise. If you're not familiar, you actually need some level of inflammation in order to be healthy, right? And to do all of your regular metabolic processes. So some level of inflammation underscores all kinds of biological processes like wound healing, bone remodeling, bone growth, obviously building muscle. If you completely dampen that inflammatory response, you actually don't get those benefits. So what we'll say here is low to moderate stress equals adaptation, right? This is true for people who tend to exercise regularly, right? It's an acute stress, but it leads to enhanced anti-inflammatory capacity over time. Whereas for people who are not well trained, right, who are just getting into exercise, people who have pre-existing conditions, sometimes older folks, too much exercise up front can lead to excessive stress. And so you can have a prolonged inflammatory response leading to muscle damage. If you do a metabolic panel, that's going to look like increases in creatine kinase, C-reactive protein, which is a marker of oxidative stress. Also metabolic stress, so that looks like increased lactic acid. So the pain and burn associated with stringent exercise is that buildup of lactic acid in your muscles. And also transient immune suppression because of an overactivation of the immune system. And so particularly for people who haven't trained consistently or are in any of those sort of pre-existing condition groups, you kind of have to manage those effects, right, to optimize both your short-term performance and your long-term health. But I do want to point out, you don't want to blunt this process entirely. Certain antioxidants, right, like vitamin C, have actually been linked at very, very high concentrations to a blunted inflammatory response, and you actually get worse outcomes later. So you have to be really careful to not over blunt this oxidative stress. But this is where molecular hydrogen really shines, right? And so let's get into that a little bit. I do want to point out that molecular hydrogen, we're not talking about protons, right? We're not talking about acids. We're talking about dihydrogen gas, right? And we have a diagram right here that shows two hydrogen atoms bonded together in an H2 molecule. Molecular hydrogen is naturally produced. Of course, the largest source of dihydrogen in the universe is a nuclear fusion in stars, but we're more interested in sources of hydrogen here on Earth. So geologically, serpentinization of magnesium and iron containing rocks creates molecular hydrogen as water breaks down those rock formations. So I think in a previous webinar, you probably heard about certain hot springs and natural waters that are high in molecular hydrogen. That is through this process. But for us, probably the most important source of molecular hydrogen gas is actually colonic fermentation, which I know is not a hot topic, but the gases that come from your microbes do absolutely impact your cellular physiology and your downstream functioning. I do want to point out, and there's a growing body of research showing that modern diets and modern lifestyles are absolutely terrible for hydrogen producing microbes in the gut. And not only that, but a lot of people appear to actually lack those microbes in their microbiomes entirely. And the reason for that is that those microbes are actually soil microbes naturally. So you get those microbes into your gut by eating like organic vegetables, right? That don't have too many chemicals on them. They're not too dead, right? Unprocessed foods, fermented foods. But naturally, we do produce some level of hydrogen gas, although a growing body of research suggests that modern people's really aren't getting very much of it. But this could be the subject of its own presentation. And if you have any questions about this, we can, of course, talk about it during the Q&A. Molecular hydrogen is the smallest bioactive molecule. It's actually the smallest molecule in the entire universe. Once you have ingested it, inhaled it, got it in your microbiome, it diffuses rapidly through your cells. It can go right through the cellular membrane. It can go right into your mitochondria and interact with those organelles. It also will eventually just diffuse out of your body entirely, just through your skin. And actually, it will diffuse through the atmosphere and back into space. But it does take a bit of time. Once it's in your cells, it can selectively neutralize certain free radicals, but not others. So a little bit of a history lesson. About 20 years ago, some of the first research really focused on hydrogen as an antioxidant. And they were looking at, can dihydrogen actually act as a direct antioxidant and quench those free radicals? And there were many like molecular assays, right? Molecular studies that showed that it can quench certain free radicals, but not other ones, but that it's actually not the strongest antioxidant. Newer research, right? So everything that's happened since then actually suggests that what hydrogen is mostly doing is regulating what's called redox signaling. So molecular hydrogen is actually acting as a regulator of cellular processes. It's regulating gene expression, it's regulating energy metabolism. And over here on the right, I've actually diagrammed out for you many of the pathways that are affected by molecular hydrogen. So the red arrows indicate pathways that are turned down, and the green arrows show pathways that have been turned up. And if you look over here on the green pathways, these are cellular protection mechanisms of various sorts. So we've seen across studies, across organisms, in cellular studies, in animal studies, and in human studies, and in fact also in plants, if you're curious, that molecular hydrogen is turning on these various cellular protection mechanisms. And that includes things like turning on the production of what's called endogenous antioxidant enzymes. So superoxide dismutase, catalase, glutathione, peroxidase, and so on and so forth. Those antioxidant enzymes are your first line of defense against reactive oxygen species, right? And if you remember back here, exercise as well as other stressful conditions lead to the production of reactive oxygen species. And reactive oxygen species, if they're not kept under control, can actually damage your cellular components. They can damage DNA, they can damage proteins, and then cause all kinds of downstream chaos. So molecular hydrogen, in a lot of different contexts, is turning on these antioxidant enzymes. It's turning on an antioxidant response network. So these are a number of genes in that network that have downstream processes that protect from oxidative damage. It's regulating vascular function. So that is really upregulating the production of nitric oxide, which is a vascular endothelial molecule. It's increasing something called autophagy and downregulating something called apoptosis. So autophagy is the process by which your cells can actually break down broken cellular material. On the other hand, if this autophagy gets out of control, it turns on something called apoptosis or cell death. So if your cells are unable to break down broken materials, and cellular components break down even just during normal functioning, they will die. So molecular hydrogen is actually changing this process toward being able to do cellular regeneration and not actually kill your cells. So that's very interesting. Mitochondrial function. So molecular hydrogen is turning on a number of mitoprotective genes, including mitophagy, which is the process of breaking down broken mitochondrial material. and just basically mitochondrial protection mechanisms. It's also turning on energy production pathways. We're going to talk a little bit later about increased energy production, right, and how that relates to exercise and physical performance. It's turning on cellular regeneration pathways. So these are sort of tangential to our autophagy pathways over here, and also turning on neuroprotection pathways. There's, of course, this could be a whole other webinar, but there's quite a lot of research about molecular hydrogen and various neuroprotective capacities. And on the other hand, it's turning off these pro-inflammatory pathways. So we already talked a little bit about the cell death pathway. It's also turning off the production of what's called inflammatory cytokines. Cytokines are proteins that act as signals to your cells. When these are produced, like if something has stressed your cells, if it's been damaged, if you have a wound, if you are sick, if you have an infection, these are produced to send basically like an SOS signal to other cells. And you do need some of this inflammatory signaling, as I said, to do regular cellular processes, but you can't let it get out of control. So anybody's heard something called a cytokine storm, which happens a lot in infections of various kinds, that if you've heard doctors or other medical professionals talk about, it's not the infection that kills you, it's the fever. The fever is that cytokine storm. And so if you allow this signaling to get out of control, it can have very bad consequences for your health. It's also turning down signaling pathways associated with chronic inflammation, signaling pathways associated with cellular stress, something called the NLRP3 inflammasome. It's also fine-tuning pathways related to metabolic imbalance and kind of rebalancing those pathways in more of the inflammatory response, and also turning down pathways associated with what's called the hypoxia-induced stress pathway. So hypoxia is a lack of oxygen. So if anybody's familiar with things like obstructive sleep apnea, right, that induces a state of hypoxia in your body. And there are studies in sleep apnea with hydrogen, and that's where this came from, where molecular hydrogen was helping to turn down that inflammatory response so that the cells would, again, be able to go through the autophagy process and kind of clean themselves up rather than dying and causing a lot of problems down the line. So we're going to kind of double back to some of these topics later on in our presentation. But one of the big questions I get as the scientist here is why, and let me go to the next slide because this will make a little bit more sense. So there are more than 150 conditions that have been studied or are under study right now relating to the use of molecular hydrogen. There's 1,500, there's actually, as of today, about 1,580 peer-reviewed studies. Peer-reviewed, if you're unfamiliar, means that scientists will do the research, they write up their manuscript, and then they submit it to other scientists to judge it. And the other scientists will determine whether it's worthy of publication or not. So these have been through the ringer to be published. They're not blog posts or anything else. So people ask me, right, why are there so many studies? Like, why are there so many conditions, right? Because we're used to things, particularly in medical instances or health, where it's like this one molecule, like for instance, a peptide, right, is linked to this one thing, right? But why is hydrogen linked to so many things? It almost sounds like a silver bullet, right? It almost sounds unbelievable. And that is because of what hydrogen is doing in the body. So all of these pathways are absolutely central to cellular homeostasis. These are really ancient pathways. They're very deep in terms of cellular functioning. And as I said, that's why we see similar responses across all organisms that have been studied, from microbes to guinea pigs, to mice, to rats, to horses, to pigs, to fish, to corals, to humans, because these pathways are central to eukaryotic cell functioning. And there are hundreds hundreds of downstream processes that are affected by these pathways. And so once a pathway has been set off, right, once the signal has been laid, you get all of these downstream responses. So it's not malarkey, but it is cellular science. The other thing I just want to briefly mention, because I get this question a lot, is how do we get more hydrogen, right? If it's doing all of this really interesting stuff, how do I get more? So we already talked about colonic fermentation, right? Fiber-rich diet. You can support the microbes in your gut to make more hydrogen gas, and that requires fermentable material. These microbes are strictly fermentative. They don't want to eat sugar. They don't want to eat protein. They want to eat fibers of various types. And then they digest that fiber and release hydrogen gas as a byproduct. And it's not just hydrogen gas that they release. They also release a number of really interesting bioactive molecules that go on to regulate metabolism. They go on to regulate hormonal balance. All of these very interesting and integral pieces of physiology are regulated by those hydrogen those hydrogen producing microbes. So you need to eat a lot of fiber to feed those microbes. You need to generate a lot of gas. But what I'm finding in research is that a lot of people actually lack these microbes in the first place. So even if you're eating a lot of fiber, you may not produce a lot of hydrogen gas. We also can bathe in hydrogen-rich water. So there is a growing number of studies showing that if you're bathing in this basically artificial spring water, right, where we are remaking the process of serpentinization to create this hydrogen-rich water in which to bathe, right? And as I said, it's the smallest molecule in the universe. It goes right through your skin, right, and into your muscles. It's a great way to get it into your muscles. We can also inhale it directly, right? Typically, inhalation is going to be about 2 to 4% hydrogen in oxygen, right? A hydrogen-oxygen mixture. This is really good if you're trying to get hydrogen into your bloodstream really, really fast. Like if you want to get it directly into your heart or your lungs or your brain. But the machines are very costly and they're an extreme explosion hazard. And I really want to underscore that. There are reports of explosions just from static electricity, not even open flames, right? And if you weren't aware, right, hydrogen gas is very flammable, so please treat it with respect. So given all of this information, the best way to really get it is through drinking hydrogen-rich water. Everybody here has kind of looked at the pros and cons at all of these and decided that hydrogen-rich water is probably the best way to get it. And there's a couple reasons for that. One, it's not going to explode. It's not flammable in this state. And we're going to talk a little bit more about how these bottles work later, but suffice to say they're not an explosion hazard the way the inhalation machines are. And you can use it at any time. Like, dare I say, this is the most egalitarian way to get hydrogen. You can use it anytime. It's accessible by anyone. It's safe for use by everyone. And an added bonus, because I know I'm always talking about the microbiome, is that there's a growing amount of research suggesting that hydrogen-rich water actually re-regulates your gut microbiome and sort of like down regulates these like bad bacteria. I don't want to call them totally bad, right? I'm a scientist, forgive me. Like nothing is black and white in science, but it's drinking a lot of hydrogen-rich water has been linked to lower abundance, basically, of what we might consider bad bacteria and a higher abundance of what we consider good bacteria. And most importantly, it's linked with a higher abundance of hydrogen-producing bacteria. So hydrogen-rich water, to me, is really the best way to go here, because you're going to get those microbiome effects, right, that affect pretty much every aspect of physiological function, right? If you've heard about the gut-brain axis, the gut hormone axis, That's all your microbes. So hydrogen-rich water is probably the way to go. But let's get on to what we're here to talk about, which is exercise. I did want to mention, right, why would an athlete choose to use this molecule versus a plethora of other things? I did a little bit of research, and the World Anti-Doping Agency would find this molecule compliant. So if this is something that's important to you, then you're probably not gonna have to worry about it, right? So the World Anti-Doping Agency has very strict standards for supplements and other molecules that are considered okay to use by professional athletes. First of all, dihydrogen is considered non-toxic. It's inert. It acts as a signal, but it doesn't create any byproducts when it reacts with anything. It's non-bioaccumulating, which means it doesn't build up in your tissues and cause you problems later. And it's also non-toxic. And I will say I've never seen anything else on this planet that has a safety profile quite like molecular hydrogen. I have seen all 1,500 of those studies. And I've also seen regulatory documents, right, put together by the United States and the EU. And no one yet has been able to demonstrate any harm from molecular hydrogen use, whether it was in the form of hydrogen water, inhaling hydrogen gas, so on and so forth. The major point of concern is always the explosion hazard. But no actual biological toxicity has been proven, which is pretty amazing considering that many things that we consider totally innocuous, like, for example, calcium or vitamin E, can actually be toxic at high levels, right? Dihydrogen is also natural, as we discussed. It's naturally produced by your gut microbiome. When we use hydrogen-rich water or inhale it, you are simply increasing the availability of a molecule that you already probably make naturally, or at least hopefully, if you have the right diet and the right mix of microbes. And it doesn't, at least in my mind, violate the spirit of sport, right? As we talked about on our cellular regulation slide, dihydrogen is really sort of restoring balance to your cellular signaling, right? Rather than sort of artificially stimulating performance. So one of the most sort of amazing things about this molecule to me is that it's really just helping your body do the things it should already be doing, but probably isn't because of life, right? Because things are stressful, because we're surrounded by pesticides and heavy metals, and and things get away from us, and we may not take care of ourselves the best sometimes. So hydrogen is really just helping the body to do what it should be doing, right? To be at its best, rather than being sort of an artificial stimulant. So let's talk a little bit about what the science says here. So to date, as of last week, there are 50 peer-reviewed human studies with molecular hydrogen and exercise science, including 30 randomized controlled trials. And we'll talk a little bit about what that means in a minute. I am going to highlight a handful of these studies and talk about what we are seeing. The first study I want to highlight, and again, if you are interested in any of the studies we're talking about, any of the references, look them up, right? Vet what I'm saying, please. You're welcome to argue with me about it. And if you want the links, just contact us. We'll make sure that they get to you. Because I personally want you to be able to dive deep into this. I want you to feel informed. Right. So the first study that I want to highlight is actually, I think, one of our more interesting studies. So this one looked at the impact of hydrogen-rich water for 6 weeks on exercise-related biomarkers in previously untrained men and women aged over 50 years. So this population doesn't show up enough in the research, but they should. And that's why I really want to highlight this study. So these were folks that were relatively healthy, but just hadn't really, they hadn't really exercised regularly, right? And if you remember back a couple slides ago, we talked about for people who don't exercise regularly, sometimes the inflammatory response from suddenly getting into exercise can be a little much for the body to handle. So these researchers found that 6 weeks of consuming hydrogen water was related to, interestingly, a significant increase in serum testosterone levels. I kind of wanted to highlight this because it goes back to what I was talking about, how molecular hydrogen has been shown to re-regulate the gut microbiome. And there's a growing body of literature showing that those microbes that utilize hydrogen as a fuel source can actually turn your stress hormones like cortisol into sex hormones, which is, to me, like extremely amazing and probably answers a lot of outstanding health questions. So I wanted to highlight that for you. They also found reductions in total cholesterol and low density lipoprotein cholesterol, as well as reduced biomarkers of acute muscular damage. So if you remember back to our slide, we were showing that exercise raises these markers of muscular damage. Well, those markers were lower after the hydrogen water intervention in people who were untrained. And incidentally, it also was found to improve sleep quality. So that, to me, is one of our more interesting studies. So the next study I want to highlight is in a younger population. So these were approximately 20-year-olds that were relatively trained, but not necessarily professional athletes. And they wanted to look at performance indicators and endurance indicators in this population. So in this study, they utilized hydrogen-rich water for 1 week prior to testing. And they found that this group had increased total power output, right? And they were able to perform an increased number of repetitions by the end of the trial. So this really shows sort of improved muscular endurance. And again, this group is a little bit more trained, right? So their inflammatory process probably isn't getting too far out of control. So once you've got that inflammatory process sort of regulated, then you can get on to your endurance and your performance characteristics. Next study I want to talk about was to me very interesting because this one was looking at the use of hydrogen-rich water to improve performance in training for where they had 2 strenuous training sessions per day. So this is like over the top here, right? Where we're starting to get into people who are really serious about their training, right? And they're training in the morning, they're training in the evening, and that can be quite hard on you. So for this group of people, and these were professionals, unlike the last 2 groups, they found reduced creatine kinase. So as we talked about, that's a marker of muscle damage. They had reduced muscle soreness, right? And also improved jump height, right? So even sort of after this brutal training regimen, they were not only able to have, less muscle damage and less soreness overall, but also increased performance. But beyond individual studies, as a scientist, I am actually more interested in what the data says when you start putting it together in a big picture. So for anyone unfamiliar with the scientific process, we usually use like this evidence pyramid to determine the validity of the evidence that we're reviewing. And the apex of the pyramid is something called a meta-analysis. And a meta-analysis is a study where we compile results from a number of other studies in order to answer a bigger question. And the reason why these are so powerful is because all of the studies you're compiling probably are different in many ways. They may have different age groups represented. They may have, both men and women. They may have, in this case, they may have people who are both trained and untrained, and just other factors, right? So different populations of people have different lifestyles, so on and so forth. And so when you pool all of your data, you can start to really see the strongest signals, and really start to get to the truth of the matter. So luckily in this space, we have 3 excellent meta-analyses to pull data from. The first one looked at 19 studies. It included 402 participants, and these participants included trained and untrained individuals, as well as elite athletes in various fields: cycling, soccer, swimming, paddling, so on and so forth. And in this study, they were asking a question about, can molecular hydrogen improve fatigue, right, in aerobic capacity? And I also want to say some of the studies used hydrogen-rich water. Some of them used like hydrogen generating powders, like in capsules. Some of them used inhalation. So all of that noise put together, what comes out of it? So they really found, again, just like we saw in the individual studies, lower, better indicators of lower fatigue, and definitely lowered blood lactate. Some of the key findings from this study were that they found in the studies they looked at that the benefits were strongest in untrained or moderately trained groups, and that chronic use of greater than 2 weeks yielded the best results. Our second meta-analysis looked really more at performance indicators than fatigue or endurance. They had 9 studies included, equaling about 165 participants. And what they found sort of consistently across studies was increased time to exhaustion. So it took longer for people to feel exhausted. Decreased sprint time, so people were faster. Again, decreased muscle soreness, decreased fatigue, decreased lactic acid. And their key findings really supported what I was talking about earlier, that molecular hydrogen was supporting that redox balance without completely blunting the inflammatory response. Because as I want to reiterate that if you completely blunt your inflammatory response, you're not going to see the benefits of exercise. It will block those benefits. So you have to have some of that inflammation. You have to feel the burn a little bit in order to get the benefits. And of course, our last meta-analysis really looked again at more physical performance. It included 27 studies, nearly 600 participants. They found, which is echoed, in one of our studies above, increased lower limb explosive power, again, decreased fatigue, decreased lactic acid buildup. So their key finding was that hydrogen wasn't acting as a stimulant in a traditional sense, but it was improving explosive movement. So jumps, sprinting, kickoffs, things like that. So I did my own unofficial meta-analysis. If you're curious, we have a database of every study. All 1,580 of those studies are data-based. I take care of it, and I pull insights from it all the time. So I did my own impromptu meta-analysis for this presentation, where I just pooled all 50 of the studies. I didn't go through the process of picking, which ones I felt were the best to include. I just included all of them, including the worst, right? And I wanted to see what would come out of it. So repeated findings, things that I'm finding across all studies, regardless of how many people were included, across sexes, across age, across training status, across modality, across timing, dosage, trial length, or even the specific activity that's being tested. I was finding the same things we talked about above. So decreased indicators of oxidative stress, decreased lactate, fatigue, and increased antioxidant capacity. And of course, these things go right back to that diagram I had earlier about all those cellular responses from molecular hydrogen. The mechanisms of action that I kept finding over and over again, right? Redox balance, that molecular hydrogen was helping to neutralize the toxic reactive oxygen species without completely disrupting ROS signaling. You can't completely disrupt it. It's really bad. But you do need to keep it under control and not let it get out of hand. Again, mitochondrial support, enhanced ATP production. So if you are unfamiliar, ATP is basically the cellular energy currency. We produce ATP in order to power other cellular processes. Again, lactate oxidation, all right, accelerating recovery, inflammation control, so suppressing that inflammatory cascade, but not completely turning it off. And as we mentioned earlier, vascular benefits, so improving nitric oxide bioavailability and also oxygen delivery to tissues. So key takeaways from what we've talked about today. So exercise builds strength. We have to exercise in order to be healthy, but it also produces oxidative stress. And that's particularly for people who do not train regularly or may have pre-existing conditions, right? Molecular hydrogen restores redox balance and mitochondrial efficiency. We saw that starts deep at the cellular level. Precision balance. So we are optimizing cellular homeostasis without overstimulation, right? And without blunting these responses that we need in order to gain these benefits. The effects are fairly consistent across human studies, which is a pretty good result to find. And basically, that hydrogen is delivering clean, stimulant-free energy. It's not energy directly, but it's energy in a couple different places. So part of that energy is helping your mitochondrial efficiency, right? So fine-tuning the engines of your cells. And part of that comes from effects on the microbiome, which I'm going to keep talking about, and one day I'll have to do a presentation on just that. So thus concludes my science portion. I do want to talk a little bit about our flask. So I went through the various modalities that you can get molecular hydrogen. As a company, as a group, we have decided that the most egalitarian approach, right, the one that is most likely to work for the most people under the most circumstances and give the most benefits regularly is probably hydrogen-enriched water. And thus we designed this sort of state-of-the-art portable electrolysis unit. So we're going to talk a little bit about electrolysis in a moment, but the flask is really neat. It has one of the biggest water capacities on the market, for one thing. We have designed it to create one of the largest outputs of molecular hydrogen in a relatively short time span. I do want to point out it won't chlorinate your water. So this is kind of a key point here. Engineers and scientists like myself recommend that you use deionized or RO water. So that's like this, if you're at the grocery store, it's like the CPAP section. The reason for that is because there's no salts or anything dissolved in the water. Electrolysis requires an active electrode and also a specialized membrane we're going to look at in a moment. And if you use tap water or other types of non-deionized water, they have those dissolved salts and they can build up on those electrodes over time. And you'll have to clean it more often and so on and so forth. But it will still work with other water sources. But let's say that you use tap water and your tap water has chlorine in it. Some weird byproducts can be produced, but we've developed a special membrane that off-gasses any of that stuff and keeps it out of the water that you actually drink. So actually this process cleans your water while producing hydrogen gas. So that's fun. We do have a great 5-year warranty, USB-C charging, so you can use pretty much any cell phone cable to charge it. And our results are certified third parties. So the performance of our products is laboratory certified to ensure that they are actually working. So there's third-party testing that uses a process called gas chromatography to measure hydrogen output. and it's probably the most efficient and accurate way to measure molecular hydrogen right now technologically. And so these test results are freely available on our website, so you can always, keep us in check. If you're curious about electrolysis, I actually love talking about this because I'm a nerd, right? And I'm hoping that you're all nerds too, and that's why you're here. So our flask is a portable electrolysis unit. So electrolysis is basically space age technology where you are applying an electric current to the water. And as we all know, right, water is H2O, right? 2 hydrogen atoms bonded to 1 oxygen atom. And when you apply that electrical current, it actually pops those hydrogens off of the oxygen and you create hydrogen gas, right? Dihydrogen, and it creates oxygen gas, dioxygen. We're only interested in the hydrogen, so we have something called a PEM, or proton exchange membrane, that allows the hydrogen to maintain, to stay in your water, and it off gases the oxygen, right? Because you don't need it. And if there's anything else weird in your water as well, it off gases that along with the oxygen, so it doesn't end up in the water that you drink, which is actually like a really interesting side effect of the electrolysis and PEM process. So look us up, right? Look on Amazon. We have a ton of reviews. People send us things all the time, right? About how hydrogen is helping them in their life. Everybody I talk to has a story, right? Even myself, right? As I said, I came into this a complete skeptic. I was like, what is hydrogen water? That sounds like complete malarkey, And as I said, I spent time digging into the research, evaluating the science, and I was quite impressed. So I decided, okay, well, I'm impressed enough. I'll actually just experiment on myself. I'll try it on myself. And yeah, after about 5 or 6 months of use, I had sort of a chronic pain condition. It was an inflammatory sort of thing from a rib injury that I had many years ago. And it's extremely improved. It doesn't hurt me when I'm sleeping anymore. Everybody has a similar story. Our customers all have similar stories. And again, I want to reiterate, as I said earlier, that chronic use, right? Consistent use is really the best. This is not something that you're going to drink once or twice and probably notice anything going on. Those cellular processes that I showed you earlier on that diagram, those take time to actually manifest as obvious changes in your body. So if you're on the fence, try not to go in with a mindset that it's going to be amazing right out of the box. It's really something that you need to be really consistent with your use and keep sending those signals to your cells, right? To re-regulate those processes. It will work over time, particularly if you have any sort of inflammatory based condition. So that's my pitch, and I stick to it. I do also want to point out, if you buy from us, if you join us as a customer, we do have an actual human customer service and support team, and anyone who has ever dealt with really awful chatbot support knows what a blessing that is, right? So I want to point that out to you. So with that, we do offer 10% discount. Please grab it. But with that, I am going to open up the floor for questions. I'm gonna check over here, see what we've got in the Q&A and in the chat. So please ask away. Anything. You've got a scientist here. I'm a biologist. So ask me the craziest question you can think of. I'll try to answer it for you. So what have we got? Okay, so one question here, Sandra asks, how how do you know if you have oxidative stress if you have no symptoms? So that's actually a really interesting question. Typically, you don't until something bad happens, right? So oxidative stress is kind of insidious. Everybody experiences it. Everybody on Earth experiences oxidative stress, even just daily. Even just the healthiest person doing, regular metabolic activity, right? Your mitochondria produce reactive oxygen species as they're generating energy, right? That is a form of oxidative stress. So everybody experiences oxidative stress. Typically, you don't really know until you've sort of reached this tipping point into the category of my tissue is so inflamed that I'm feeling pain from it, right? Or my complexion is getting ruddy, or my hair is getting thinner. So if you are worried, right, that you're sort of falling into the over inflammation category, there are tests that your doctor can do to look at some of the biomarkers of oxidative stress. We talked about one of them earlier, the CRP or C-reactive protein. There are other biomarkers as well of tissue damage, of lipid oxidation, so on and so forth, like malondialdehyde. So, ask your medical professional that you trust to perhaps run a panel. But do keep in mind that everybody does experience oxidative stress. And, one thing about running panels like that is it's just a snapshot in time. So you don't understand, like, maybe I went on a bad day. So it's really one of those things you probably want to keep an eye on. But yeah, it is insidious and you often don't know. I read that the body produces 12 liters of hydrogen daily. So it can, right? So now one thing here I want to point out. When we think of the word 12 liters, we're thinking of 12 liters of water. 12 liters of gas has several orders of magnitude fewer molecules in it as a volume, right? Than the same volume of water. So think about 12 liters of empty balloons, not like 12 liters of water. But yeah, if you have the right microbes and you are eating lots and lots of fiber, you can produce quite a bit of hydrogen gas. For inhalation, how long per session? So I'm going to answer this from a research perspective. I'm not a clinician, right? I'm not a medical professional. In the research, I have seen studies anywhere from a 10-minute session to a full day session. I would take this up with your medical professional. Take them some of the studies, right, that pertain to your condition and determine a proper regimen, because the research is all over the place. Ed, increased libido or increased free testosterone. So no studies so far have looked at sexual performance or libido per se. There are a handful of studies showing increased free testosterone. So it's really a preliminary result. And I'm really hoping more research is going to come out, or I can get into actually doing more research on this to dive deeper into those questions, because they're super important ones. But nobody has looked at like the psychological or performance aspects of that. Okay, if I drink 10 cups of water each day, what percent should I try to drink as hydrogen water? I agree with Penny here, probably 3 to 6 bottles. If you're curious, I drink 2 and my husband drinks 3. But you can drink a little more, but I would just say anything in life, enjoy with moderation. So don't overdo anything, including this. Precautionary principle. Any studies on older individuals, 70s and 80s, safety issues? So there's a growing number of studies in that population. The majority of those studies look at like metabolic related stuff. No safety issues have been reported in that population or any other population. Let's see, any research shows taking hydrogen water with creatine or whey protein increases its absorption. So no, there are a handful of studies that combine hydrogen with something else. For example, off the top of my head, there was one, I think, that looked at tea polyphenols, for example. I think there was another one with ginseng. They didn't look at absorption. They just looked at the compounding effects of those complementary supplements, but none that I can recall that looked specifically at creatine or whey protein. Interestingly, if you really want to get into the nerdy side of this, there are a handful of studies that have come out in the past couple of years showing that, like in a lab setting, that using hydrogen water to like extract plant materials, like making tea, actually increased the amount of bioactive components extracted from the plant material. So I would say there's some argument to be made that it might aid the digestion of these materials, but there's no testing on that. Okay, I'm still fuzzy on how the membrane filters out the oxygen and other gases. Yes, let me bring back that slide for you. So this is obviously a schematic. So this particular membrane is made of a particular material that does something called steric hindrance. All right. So there are many types of filters in the world. That the ones we are primarily used to are the ones where pore size is what matters, right? So, they physically block a material from going through because the pore size is too small. This particular membrane is interesting in that it has a chemistry called steric hindrance. So it allows protons, if we were doing acid-base chemistry, we're not. And it also allows dihydrogen, because actually a full dihydrogen molecule is not that much larger than a proton, believe it or not. It allows it to pass right through because it's totally neutral and it's extremely small. Whereas oxygen, dioxygen gas, is a hugely bulky molecule that is several orders of magnitude larger than a dihydrogen molecule. And a lot of other contaminants that could possibly be in your water, for example, chlorine gas, is also a really huge, bulky molecule at the microscopic level compared to hydrogen. So these huge, bulky molecules are blocked from passing through into your water, and they're off-gassed in a little port at the bottom of the flask. So I hope that helps. Does it have a battery? Can you take it on a plane? So it has a lithium-ion battery. Check with your airline and their lithium-ion battery policy. How does distilled compare to RO? So distilled water and RO are both free of salts. The main difference is the industrial process used to create that salt-free water. So distilled water uses the process of distillation, which means that they boil the water and they collect the steam, and the steam is free of salts. In reverse osmosis, they actually have a special membrane that allows the water to pass through, and it concentrates all those salts within the membrane. So you get salt-free water on the other side. So the end result is salt-free water. It doesn't matter if we use DI or RO, it's kind of whatever's available at the store. And okay, so the concerns with greater consumption. So I think we're talking here about an osmolarity effect. So if anyone has heard, right, that you really shouldn't drink too much RO or distilled water, that's because your cells have a certain amount of salt in them. And if you consistently, forever, chronically drink water that doesn't have any salt content, it can cause an osmotic disbalance. But for the amount of water that you're drinking in 3 to 6 flasks per day, that is unlikely to become a problem. We're talking about drinking gallons and gallons of the stuff. Can the flask help me with kidney disease? There are some studies in kidney conditions, and I would encourage you to get those studies and actually take them to your doctor before determining, whether you should do this. I will say, in terms of like how many flasks should I drink, the interesting thing about the research, as I've dived into it and seen the cellular effects that we talked about, those results were, again, the result of my own meta-analysis. So across organisms, across disease models, across health status, across modality, right? Whether somebody was drinking it or inhaling it or whatever, and also across dosage and timing. And so I don't have like a really good answer on like what is the best amount to drink. What it appears to me, based on the research, is just drink enough to get a consistent cellular signal. And that may look different person to person. So with the kidney studies, I have compiled all of these studies on a website called hydrogenstudies.com, which basically houses our database. I looked at it today and I think it might be down. So I would recommend you head over to a website called PubMed, which is hosted by the US government, and look for hydrogen, water, kidney health, and take those to your doctor. Is it too late to drink it? I think this kind of differs person to person. I think Penny's advice here is probably pretty good. I drink it during the morning. That works out. Should I drink before or after exercise? So interestingly enough, different researchers have tested many different ways to take it. So in some of the studies, they drank it 30 minutes. The most common was 30 to 60 minutes before an exercise session. But some of the studies looked at it where they were doing it like while exercising. And some of the studies were more like testing performance in people who were just drinking it consistently. So in some of those studies, they kind of allowed the participants to drink it at any time of day. But the most common timing across those studies was 30, 60 minutes before exercising. So what percentage of hydrogen makes it into the blood? So off the top of my head, there are a number of biophysical studies that show this. I think it's on the order of 5 to 20%, but I'd have to look back at those biophysical studies. If you want those studies, contact me/us, and I'll get those to you, right? So you can answer that question. Most of it makes it to the stomach, liver, and lungs. So the interesting thing is, one, it sort of depends on the modality, right? Whether you're drinking it or inhaling it. There are also studies showing that they actually inject it directly into people's like veins, like hydrogen-rich saline. And there are other studies where it was like peritoneally injected. So it appears that if you are drinking it, it primarily gets directly into your digestive organs. And a lot of the downstream effects are mediated by the microbiome, which has its own benefits. And that's why I kind of prefer it. The inhalation studies really show that it's kind of getting directly into the things that are pumped by your heart very fast, right? So it's going directly into your lungs, to your heart, typically to your brain, and also to your spleen. But they're kind of inconsistent. I mean, there's one of the biophysical studies showing that one of the biggest organs that was receiving it was the muscles, while another study said that was not the case. So if you want to have the biophysical conversation, please contact me and we'll work it out. How many months until lab work shows improvements? Yeah, there's really no one answer to that. As I said, across many studies, it's chronic use of at least 2 weeks, but up to more like 5 or 6 months, like what worked in my case. That seems to be the most effective, but it does take time. It's not immediate, right? Because you're working through those cellular cascades. Does it make supplements or medication work better? There is currently really no answer to that in the research. So that's kind of an open question that I certainly have. There are a couple studies showing that for medications that are very stressful on you, that it does kind of help people handle that stress better. But again, I would grab those studies and take them to your medical professional and really work out an answer that suits you. Let's see. Hydrogen water intake, reduction of RA symptoms. There actually are some studies in rheumatoid arthritis. And let me take you back to one of my slides here. I think this is going to help a lot of questions. Let me go back here. So these cellular cascades, right? These ones that are green are dysregulated in a number of chronic conditions. And these ones that are red are upregulated in those same conditions. These cellular pathways are at the base of hundreds of downstream effects. So they affect, you know, your redox signaling, they affect your metabolism, they affect tissue turnover and wound healing. And so in many, many chronic conditions, like for example, I'm thinking back to grad school when I was learning biochemistry, and the way we would do this class is that the first half of the semester was regular biology, right? Regular physiological functioning. And the second half of the class was diabetes. And the reason why we did it like that is because every one of those physiological mechanisms that we learned about at the first part of the class was turned on its head in diabetes. So everything that was good was turned bad is kind of what I'm saying. So I wouldn't really look at molecular hydrogen as a cure for anything specific. What it's doing is re-regulating these cellular processes, regardless of anything else. These results that I've shown you here in this diagram are the result of my analysis of all of those 1,500 studies. And again, that's across organisms, that's across disease states, that's across health status, that's across modality, all of this. And these same pathways are turning up over and over again. So if you are afflicted with a condition where one of the underlying mechanisms of that condition is a dysregulation of one of these pathways, it might be something to look at. But again, I'm not a clinician, I'm a biologist. So I really recommend that you look at the research and you get it and you take it to your doctor and you talk about how this might affect your condition. Let's see. Chemo and cancer support, radiation therapy. So there actually are a growing number of studies here. And this is there are a growing number of human studies here where it is showing that people who are undergoing chemotherapy or radiotherapy obviously have quality of life problems because of those treatments, and that molecular hydrogen was helping those people lead a better quality of life. Again, if you go to, while my hydrogenstudies.com is down, that's my best resource, but go to PubMed and look this up, right? And those studies will come up, and take them with you, right? Because I'm not here to give you medical advice, but this is a really interesting cellular process. How long does hydrogen water stay good? Yep. Listen to Penny's advice. She's good. All right. So I think that's all that's in the Q&A. Let me look over here in the chat. If you have any last minute questions, please send them in. Hydrogen and fat metabolism. Yes. So there are quite a number of studies looking at fat metabolism. One of the most interesting recent studies that came out in the last couple months showed that chronic molecular hydrogen supplementation was actually increasing people's endogenous GLP-1, right? So I think everybody knows what GLP-1 is because, the buzz all about GLP-1 agonists. So that is a hormone that your body makes to make you feel more full and to help you sort of eat less. And also sort of to support fat metabolism and weight loss. So that was one of the more interesting results that has come out recently, was that it was helping those patients to create their own GLP-1. And there are a number of studies showing increased fat metabolism and small gains in weight loss, not like extreme weight loss. I think that's all the questions. Oh, I saw something come up here. Ghrelin production. So there's one study kind of showing this, but to me, it's not the strongest study. This is sort of an open question, and I'm really, I'm trying to support more research in that direction. Okay, so I think that's all the questions. So I'm going to maybe call it here. Thank you, everybody, for coming. If you have ideas for things you want to learn more about for future webinars, please, send them in. If you're trying to find research, contact us. I'm all about the science, right, and finding the right answer. Not too interested in being overhyped, but I do want to impress on you that this diagram here is actually really kind of groundbreaking in that these, as I mentioned, these cellular processes are absolutely central to so many aspects of physiological functioning, and their downstream cascades affect hundreds and hundreds of downstream processes. And I think probably, to me, one of the most interesting things about molecular hydrogen is, in fact, that our gut microbes do make it. So, people who really read a lot about diets and health and things like that, you've probably come across research showing that certain types of diets and lifestyles are related to longer lifespans, lower rates of cancer, lower rates of chronic disease, right? And these diets tend to be high in fiber, right? Fiber rich, a lot of whole plant foods, whole foods, and kind of lower in fat, lower in sugar, right? So Mediterranean diets, traditional, Japanese and Korean diets, but definitely not the Western diet, right? Which is high in sugar, high in fat. Those traditional diets are extremely conducive to the growth of these hydrogen producing microbes. And my hypothesis, my big overarching hypothesis in the research that I'm doing, is that because we've basically killed that aspect of our microbiome, we're no longer getting this molecular hydrogen in our gut anymore, right? And so now what are we seeing, right? If you look in the epidemiological data, we're seeing, extreme increases in chronic diseases, extreme increases in cancer rates, lowering lifespans, all kinds of autoimmune and inflammatory disorders, right? And I think that this is directly related to our dysregulated microbiome. So using something like hydrogen-rich water kind of bypasses the microbiome a little bit so that you're gaining the benefits of that gas that would have been naturally produced, but you're maybe not making enough of it. And also, as I mentioned earlier, a growing number of studies are showing that hydrogen-rich water is actually helping to re-regulate the microbiome to get it back into a healthier state. So it's like a double whammy of good. So it's probably a long-winded way of saying that I am excited about this, and I hope that you are, and I hope that we can have more webinars in the future. And if you have things you really want to learn about, you want to dive deep, please send them in. And I would love to put together more of these talks for you. And with that, I will bid you adieu, and I hope to see you again in the future.